The introduction. Fish is an important food. We need to monitor the fish and manage the fishing activity so that we can have good fish with cheap price. And the fish have time to reproduce themselves, and they should not be in danger of extinction. Every year, did you ever have many survey trips in the Danish water to estimate the distributions of fish? The information were used to give advice to the ministry to give fishing quotas to the fishermen. So it would be nice if we have something like a fish focus. The methods for fish identifications are very important. They have a great economic potentials. They affect the accuracies of the surveys. They affect the income of the fishermen. And an ideal method would be a method that provides maximum accuracy information of fish and is inexpensive. So how is the state of the art in the acoustics methods in this field? Now they on the survey and the fishing vessels have echo sounders that usually mounted in the hull of the ships. The center frequency is usually below 500 kilohertz, and the swim bladder of the fish is an important effect because with the current methods they use the methods that depend on the swim bladder, the size of or the orientation of the swim bladder of the fish. So it is difficult to identify fish without the swim bladder. The data of the fish usually are displayed at red, green, blue blobs, and the data are saved to be processed data. To ground truth the acoustics data, trolling has to be done, and the identification of the marine organisms are done on board the vessels. The fish afterwards will be released back to the sea, but most of them are dead. The pros and cons of the state of the art. The advantages of those methods are that they are well established, have a long history. The fish can be detected from at least 500 meters. The advantages are the drawbacks are that surveys are time consuming and very expensive because they require trawling. The fishermen cannot select the most economic allocation of fish, and it's a waste of fish resources. So what is the possibilities and opportunity for improvement? The development of new platforms such as the AUV or the ROV make it possible to get closer to the school of fish, so we can use the acoustic sensors with better resolution, higher frequency, broadband, but with shorter range. In this direction, new commercial on-sound imaging devices has been developed, such as the blue wheel sonar or the dual frequency identification sonar. Those devices can show the shape and orientation of fish, but they can still not identify fish. Those devices also expensive, and it's difficult to replace them if lost at sea. So is there any cost-effective methods? We at the DUF try to investigate in that direction. First, we did experiment with an ROV that have a sonar as well as underwater camera. Here is an example of two pictures taken at the same time. This is the sonar picture, and this is a photo from the underwater camera. we can see the orientation of the fish, we can see the fish, but there are still no methods to identify them. So in another experiment, we scan the fish with the medical ultrasound scanner at the 12 megahertz along the fish length. We scan two fish, one blue whiting and one carp. Those are the ultrasound image of the fish, and from those we can clearly see what kind of fish are they, so we can identify fish at 12 megahertz. But the range that we can get the data can only up to 30 centimeters. New approaches. So in my knowledge, libraries of range profiles only been used in military to identify aircrafts or tanks, and we would like to adapt these methods to identify fish. We propose 3 new studies to build the libraries. First is to the understanding characteristics of ultrasound backscatter from fish in the megahertz frequency range. The second study is the methods to generate simulated range profiles, and the last one is the empirical measurements of the range profiles. But for fish, it's more complicated because the fish are not stiff. So can we identify fish from the 3 studies? Now we come to the first study, empirical ultrasound backscatter from fish. We have some hypotheses for this study. First is that the ultrasound backscatter of a certain type of fish have patterns that characteristics for that type of fish. The patterns for 2 different types of fish would be different. The mentioned above characteristics would be valid for most of the frequency in the megahertz range from 1 up to 12 megahertz. The part of the fish that contributes to the backscatter would be the bone structure, the skin, or the heart structure, and the screen bladder would have little contribution to the backscatter. And the procedure to measure those ultrasound backscatter would be repeated or can be reused to measure for many other orientation of the fish. This is how we set up the measurements. First, we put the fish in an aquarium, and then we use transducer connect to an ultrasound scanner to scan the fish, to scan along the fish. The scanner will move by a mechanical scanner. The data are transported to the desktop computer and saved here. M is a material to avoid standing wave and reflection. To adjust the angle between the fish and the ultrasound beam, we use angle adjustment device. The photo of the device is here. And this is a photo of a real measurement. We did the measurement on